Welcome to another deep dive. We're going on a bit of a learning adventure today.
Oh, sounds fun.
It is. We're going to be taking a look at open educational resources,
Okay,
specifically a project called Open Source Physics at Singapore.
cool.
And I'm really excited about this one.
Why is that?
Well, you know me, I love to learn by doing,
Yeah.
and this project is all about making physics fun and accessible using easy Java simulations.
Oh, wow.
Which I think is going to be perfect for everyone listening who, like me, love to get hands-on.
I can see why you're excited about this one.
I am. I think this is going to be really cool.
I can see it.
So to get us started,
Yeah.
maybe you can give us a little bit of context
Sure.
about open educational resources
You bet.
and why they're so important.
Yeah, so open educational resources, or OERs as they're often called,
Okay.
are becoming super important in education. And it's because they offer free access to high-quality learning materials.
Which is
Which is huge. Yeah, it can be a total game changer for students and educators all over the world.
totally. And we're diving deep into this specific project
Right.
by following a trail of breadcrumbs starting from their website.
Okay.
We landed on a page describing an event that really caught my eye.
Oh, tell me about it.
It's a workshop
Okay.
at River Valley High School
Cool.
called Physics Subject Chapter Brown Bag Series,
Interesting.
where teachers are encouraged to learn alongside their students.
I love that.
I do too.
That's such a cool concept.
And what I found really interesting is this workshop focuses on using Java simulations to build simple physics models. I'm curious to know more about how this approach works.
Yeah, well, the philosophy behind it is called constructionism.
Constructionism.
Yeah, it's this idea that people learn best by actively creating and building things.
Okay.
So in this case, using Java simulations allows teachers and students to kind of construct their own understanding of physics concepts.
So they're not just reading about them.
Right, exactly.
Yeah. They're actually making them.
They're manipulating variables, they're running experiments, and they're seeing the results in real time.
That's awesome. That's like having a virtual physics lab at your fingertips.
Yeah, exactly.
I love that.
Really cool.
And the page mentions that they were using these models for active inquiry learning.
Oh, yeah.
What does that mean?
So active inquiry learning,
Yeah.
it's all about encouraging students to ask questions,
Good.
explore ideas, and find solutions through hands-on experimentation.
I like.
It's a move away from that traditional model of passively learning.
Right, where you're just taking in information.
Yeah, exactly, from a teacher or a textbook.
But they're becoming a participant.
Exactly. They're empowered to be active in their own learning.
I love that.
It's great.
So it's not just about memorizing formulas,
No.
but actually understanding the underlying principles.
Exactly. And it's so much more engaging and effective, it's been shown.
I bet. I could see how that would be much more fun and interesting.
Yeah, absolutely. And this workshop seems to be a perfect example of how open educational resources can be used to facilitate this kind of learning.
Like they're giving the teachers the tools.
Yeah, they're equipping teachers with the tools and empowering them to create these really interactive and engaging lessons.
I love that.
It's great.
Did you happen to notice? They even included a link to the refreshments menu.
Oh, really? Let me see that.
Yeah, apparently they planned a pretty amazing spread.
Wow, look at that.
7 courses in a beverage,
Not bad.
only $4 per person.
Wow, that's a good deal.
Big shout out to Suji for organizing that.
Good job, C.
I know, right?
Oh, very cool.
But aside from the delicious food, I did want to get back to the learning side of things.
Of course, yeah.
You know, what kind of impact does this approach actually have?
Oh, yeah, that's a great question.
Does it actually improve learning?
It does, actually, yeah.
Recent-
Studies have shown that this constructionist learning can lead to improved problem-solving skills, deeper conceptual understanding.
That's what we want.
Yeah, and it also boosts student motivation, which is great.
That's awesome.
Yeah, so it's not just about making learning fun.
Right.
It's backed by research.
Which is important.
It is, and it shows real benefits.
That's cool. I like that.
Yeah, and you know, another thing that's great about this workshop page,
Oh, yeah.
it highlights 2 really valuable resources,
Okay.
their websites.
Okay.
One is compadre.org at JASPA,
I'm writing this down.
and the other is phy.ntnu.edu.twntnewjava.
Okay.
And these websites offer a ton of pre-built Java simulations
Oh, cool.
and tools for creating custom models.
So you don't have to start from scratch.
Exactly.
You can use what other people have already done.
It's fantastic. They're like gold mines for educators
Wow.
who are looking to incorporate this approach into their teaching.
I'm definitely going to be checking those out later.
You should. They're really great.
I noticed the event was also posted on Facebook.
Ah.
It seems like a pretty diverse group of people attended.
Oh, yeah.
We see teachers listed like Julie Kwa, Ong Shi-hwa from Innova Junior College,
Cool.
Lai Si from
Yeah.
Beacon Primary School,
Okay.
Ang Juliak,
Uh-huh.
Yuan Tao, and Lim Ai Feng from River Valley High School.
Great.
But there's also Lukeng Lawrence Wee from the Ministry of Education.
Oh, wow.
That's pretty cool.
That's great. Yeah.
So it's not just teachers.
No, it sounds like there's some real support behind this initiative.
It does,
To
right?
have representatives from the Ministry of Education there,
Yeah.
alongside teachers from various levels of schooling,
Right.
suggests this project really aligns with broader educational goals in Singapore.
Yeah, and it's not just a one-off thing either.
What do you mean?
This workshop is just a small piece.
Oh, okay.
Open Source Physics at Singapore has an extensive list of other projects and events on their website.
Wow, really?
Over 100 to be exact.
That's incredible.
I know.
What other kinds of things are they doing?
Well, we're about to find out. But before we do,
Yeah.
maybe we could take a quick look at this list.
Sure.
Because I'm seeing some really intriguing titles here.
Okay.
Like 2003-1007 Collaboration in Flight and Aerospace Teaching and Learning Program.
So they're going beyond traditional physics topics.
It seems that way, right?
Yeah, that's really interesting.
And then there's Open Source Physics at Singapore Ministry of Education, Gold Energy Award 2016 HQ,
That's amazing.
which really speaks volumes about the impact of this project.
Yeah, they're clearly making a real difference.
I think so.
It's great.
And then we have things like Cititration Curve Generator by Grace Leong.
Oh, cool. So they're highlighting individual contributions, too.
It seems like they're really trying to foster a sense of community
Yeah, that's fantastic.
and shared learning.
It's really impressive.
I'm also really curious about this one. All building iOS app from Ionic Projects.
What's that all about?
I was wondering the same thing.
Are they making their own apps?
Maybe. To
Yeah.
make these resources even more accessible.
That would be very cool.
I think so too.
Especially for students who are already comfortable using mobile technology.
You're right. It's like they're constantly pushing the boundaries of what's possible
They really are.
with open educational resources.
This is a really impressive project.
It is. And if you scroll down to the bottom of the page,
Okay.
you'll see a list of popular tags.
Uh-huh.
And these give you a glimpse into the sheer breadth of topics they're covering.
Like what?
Well, you see things like tracker software, easy JavaScript simulations,
Oh, good.
specific concepts like the kinetic model, electromagnetism.
Wow. So they're really covering a lot.
They are. They've managed to achieve so much.
Yeah, it's pretty incredible.
It really shows you there's a vibrant community dedicated to making physics education more engaging and accessible for everyone.
That's fantastic. It really embodies the true spirit of open source learning.
I think so too.
The collaboration, the innovation, the commitment to sharing knowledge.
And they've created a dynamic ecosystem of resources that can benefit learners at all levels.
That's amazing.
This is already so inspiring.
Yeah, I'm really enjoying this.
And we've only just scratched the surface.
I can't wait to see what else we find.
Me too. But before we move on to the next part,
Okay.
I want to go back to those Java simulations and tools.
Sounds good.
I'm particularly interested in seeing how they can be used to visualize complex physics concepts.
Yeah, me too. They sound really interesting.
So let's dive into those in the next part of our deep dive.
I'm ready when you are.
Okay, so we're back and ready to take a look at those Java simulations.
All right, let's do it.
I'm on compadre.org's PORP right now.
Okay.
And wow, there's a lot to explore here.
I bet.
Where should we even begin?
Well, I think since we were talking about constructionist learning and active inquiry,
Right.
we could start with a simulation that allows for a lot of user manipulation.
Okay.
Like one that comes to mind is the projectile motion simulation, like a classic physics concept.
Yeah, for sure.
And I think it really shows how powerful these tools can be.
Okay, I found it.
Great.
It looks pretty straightforward.
Yeah.
You can adjust the launch angle, initial speed. You can even add air resistance.
Cool.
That's cool.
Yeah.
I'm already starting to see how this could be more engaging
Right.
than just looking at diagrams in a textbook.
Totally.
This is way more fun.
For sure. So instead of just memorizing formulas,
Right.
students can actually see how changing different variables affects the projectile's trajectory.
Right.
And they can do it in real time.
That's so cool.
It is. And it encourages them to ask questions like, what happens if I increase the launch angle?
Right.
Or how does air resistance impact the distance traveled?
Yeah.
It turns learning into this process of discovery.
It does.
It's really cool.
And it's fun, which is important.
Yeah.
I'm playing around with it right now.
Yeah.
And it really is fascinating to see how these changes play out visually. It's like having a virtual testing ground.
Exactly.
Where you can try out different scenarios.
And there are no real-world limitations.
Exactly.
Yeah, so that's one of the best things about simulations. It's a safe and controlled environment.
Right.
Students can make mistakes, try again.
Which is how we learn.
Exactly, and they learn from their observations.
Without having to worry about, like, breaking something.
Yeah, exactly.
Or, real-world consequences.
Yeah, for sure.
I bet this type of learning also helps them to develop a deeper understanding of the underlying physics concepts.
Oh, absolutely.
Because instead of just plugging numbers into an equation,
right,
they're actually seeing how those concepts work in a visual and interactive way.
It's so much more effective.
It is.
It's really cool.
And I bet it also helps them to see the connections between different ideas.
Oh, for sure.
How they relate to each other.
Absolutely.
Like, for example, maybe they start to see how force, velocity, and acceleration all play a part in projectile motion.
They're all connected.
Right. It's like they're building a more holistic understanding of physics.
Exactly.
Instead of just memorizing isolated facts.
Yeah, it's really about understanding the bigger picture.
It is. And the great thing about open educational resources like this is they're constantly evolving.
They are.
Educators from all over the world
Yeah.
can contribute to these platforms.
Right. They can share their own simulations.
Lesson plans, ideas.
All kinds of things, yeah.
And it creates this really dynamic ecosystem
It does.
of learning resources that's constantly being improved.
Yeah, and it's really a testament to the power of collaboration.
It is. It's amazing.
And the dedication of these educators.
Right. And so it's not just a static collection of simulations.
Yeah.
It's this living, breathing community
It is.
of educators who are passionate about making physics education more accessible and more engaging.
They're really amazing.
They are, and it's not limited to physics either.
Oh, really?
There are similar open educational resource initiatives
Wow.
for all kinds of subjects.
Like what?
Math, biology, history, literature.
Really?
It's amazing.
That's incredible. I had no idea.
I didn't either until I started doing research for this deep dive.
It's really opening my eyes to the potential of open source learning.
Me too.
There's a whole world of resources out there.
I know, right?
Just waiting to be explored.
It's exciting and a little bit overwhelming.
Yeah, I know what you mean.
But it makes me wonder, what are the implications of this movement?
Yeah, that's a good question.
If these resources are so readily available, could they potentially change the way we think about education?
That's possible, yeah.
I mean, they could provide greater access to education for people all over the world.
Yeah, regardless of their background or location.
Right. It could level the playing field.
It could, yeah.
And give everyone an equal opportunity to learn.
That's the goal, right.
It is. And it could also empower educators to break free from those traditional textbook-based curriculums.
Yeah, that'd be great.
Create more engaging and personalized experiences for their students.
Absolutely. There's so much potential.
It's very exciting, but
Yeah,
I'm also thinking about the challenges
yeah, I know what you mean.
involved in adopting open educational resources more broadly.
Yeah, there are definitely some hurdles.
Like, what are some of those?
Well, I think one of the biggest ones is awareness.
Oh.
A lot of educators just don't know.
They don't even know these things exist.
Yeah, they don't know about all these resources.
It's like having a treasure chest.
Yeah.
But nobody knows how to open it.
Exactly.
So raising awareness and providing professional development.
Sure.
Those are really crucial.
Yeah, and another challenge is quality control.
That's a good point. Yeah.
There are a lot of high-quality, open educational resources out there, but there are also some that are not so great.
Right. So how do you make sure that people are using the good stuff?
Exactly. So it's important to have mechanisms in place.
Right.
To make sure educators are using resources that meet certain standards.
Right. So it's like a balance between openness and quality.
Exactly.
You want to encourage sharing and collaboration, but you also want to make sure that the resources being used are actually effective.
Absolutely. And that's where organizations like Open Source Physics at Singapore are so important.
Yeah.
They're creating and sharing high-quality resources,
Mm-hmm.
but they're also providing support and guidance for educators who are new to this.
It seems like they're really taking a leadership role
They are,
in
yeah.
this movement.
Yeah, both locally and globally.
I'm feeling really inspired by everything we've talked about today.
Me too. It's really cool.
It's amazing how something as simple as sharing educational resources can have such a huge impact
They really
on learning and teaching.
Yeah, it's pretty incredible.
It's a reminder that education isn't just about memorizing
Or
facts.
passing exam.
It's about fostering a love of learning,
For sure.
encouraging exploration,
Uh-huh.
and empowering individuals to reach their full potential.
Yeah, I love that.
And the resources that we've talked about today really embody that spirit.
They do.
They provide a glimpse into a future
Yeah.
where learning is more accessible,
More
personalized than ever before.
It's really exciting.
It is.
What do you want to talk about next?
Well, their website mentions a lot of projects and initiatives
Okay.
that go beyond just creating simulations.
Right.
I'm curious to learn more about those.
Yeah, me too.
Let's delve into that in the final part of our deep dive.
Sounds good to me.
All right, so we've explored those amazing Java simulations,
We have.
and we've talked about the wider impact of open educational resources, but now I want to circle back to all those other projects
Right.
that Open Source Physics at Singapore is involved in.
Okay.
Because it seems like they're not just creating resources,
Right.
but they're also really building a community
Totally.
around open source learning.
I agree. They're going above and beyond just providing the tools. And they're taking this really multifaceted approach to promoting OERs.
Like what?
Well, for example, remember that project title we saw earlier?
Which one?
The 21-3-1007 Collaboration in Flight and Aerospace Teaching and Learning Program?
Oh, right. Yeah, the one about aerospace.
Yeah, exactly.
What about it?
Well, it's a perfect example of their collaborative efforts.
So they're reaching out to other institutions
They are.
and experts to develop these really specialized learning materials.
Right, even in niche fields like aerospace.
Which is amazing.
It's super impressive.
I'm very impressed.
And it highlights another key aspect of their approach.
What's that?
Interdisciplinarity.
Okay.
They're not limiting themselves to just physics.
Yeah, I noticed that.
They recognize that open source learning can benefit all sorts of subjects and fields.
Right. And the more you connect different disciplines,
Yeah.
the richer the learning experience becomes.
Exactly. It's all about making connections.
And speaking of connections, remember their Open Source Physics at Singapore Ministry of Education Gold Energy Award 2016 HQ.
Oh, yeah. How could I forget?
I mean, that's huge.
It is.
Getting that kind of recognition from the Ministry of Education.
It shows they're making a real impact.
It does, right.
Their efforts are not going unnoticed.
And it also suggests that there's growing support
Yeah,
at an institutional level
for sure.
for open educational resources in Singapore.
Which is really important.
It is, because it's not just about
Mm-hmm.
individual teachers using OERs.
Right.
It's about changing this system.
Yeah, creating a systemic shift
Exactly.
in how we approach education.
And it seems like Open Source Physics at Singapore
Yeah,
is leading the way
I think so.
in making that shift. So how are they doing that?
Well, one of the ways is by organizing workshops and conferences.
Okay.
These events give educators a space to connect, share their experiences with OERs, learn from each other.
It's like they're building a community of practice
Yeah, exactly.
around open source learning.
It's so important,
It is.
especially when you're trying to introduce new approaches to teaching.
Right. Because it can be challenging.
It can, for sure.
And having that support network of people who get it,
Who understand the challenges.
who are passionate about it.
It makes a big difference.
It does. And it's inspiring, too,
Yeah, it's great.
to be part of something bigger than yourself.
It is. It's really about recognizing that we can achieve more together.
Absolutely.
It's a shared responsibility.
Well, this has been an incredible journey.
It has.
We started with a website about Java simulations.
Right.
And now we're talking about a movement that has the potential to completely transform education.
Yeah, it's amazing how these things happen. It all starts with a small idea.
And then it ripples out.
And who knows, maybe our listener will be inspired
I hope so.
to create and share their own learning experiences
I hope so, too.
with the world.
That would be fantastic.
That's the beauty of open source learning.
It is. It's really empowering.
Yeah,
Well, this has been another fascinating deep dive.
it has been fun.
I've learned a lot.
Me too.
And I hope our listeners have, too.
I hope so.
If you're feeling inspired to learn more,
Yeah.
check out the resources that we talked about today.
Explore, have fun.
And see where your own learning journey takes you.
You never know what you might discover.
Thanks for joining us.
Thanks for having me.
And happy learning.
Happy learning.